Hi, and welcome to this short demonstration of Polygonica's sheet thickening functionality. As usual, please note Polygonica is not available as an end-user product. It's a software library or component that's licensed by software developers as an advanced geometry engine that sits inside their CAD, CAM and CAE software. You can see some of Polygonica's customers here and also on the Polygonica website. So, onto the demonstration, which I'm going to run live on my 4-year-old Dell laptop. The model displayed here is part of a car door panel. It's a single sheet, and if you look at the top right here, you can see it's around 418,000 polygons. That's representing a 20 megabyte binary STL file on disk. If I spin it around and look from the back, in this demo application, we're not drawing inward-facing polygons, so you can see straight through it, which is just a way of demonstrating that it is actually a single sheet. Similarly, these green lines are drawn around all the open edges. So an open edge is an edge to which only one face is attached. In a normal closed solid, we'd expect each edge is shared between two faces. So I can just render both sides, so render the inward sides of the polygons. I just turn off the edges and then zoom in and see that, yeah, we do have a single sheet here. So on to doing an offset. So I'm going to offset this by a distance of 1 millimeter. If we look at the dimensions of the part, it's about 1.3 meters across and 800 millimeters in the other dimensions. And I'm just doing a small offset because you can see here there's this very narrow fold over. So I want to preserve that in the offset. So if I click offset in. So whilst the part's offsetting, I'm going to mention that we're applying a spherical offset. So the resulting solid has a constant thickness across the part. The offset process in Polygonica is underpinned by the same Boolean engine that's used inside the market-leading MachineWorks software for CNC Simulation and Verification. So Polygonica and MachineWorks actually share the same core technology base. So this process does take a little bit of time, but by way of contrast, if you tried to do this kind of offsetting or thickening in a CAD system using BREP surfaces, you'll find it will very probably take tens of minutes or possibly even more than an hour, or even in some cases several hours to complete the actual offset thickening process. In this case, Polygonica's done it in 50 seconds. And so we now have a nice thickened sheet. You can see the polygon count's gone up because we've in effect doubled the number of polygons because there's now a front and a back. And you can see the results very clean, even though there's some fairly complex geometry here. And where are they? Those little foldovers have been offset nicely as well. So just by way of illustration, I'm going to undo that and go back to the original. So we're back to the original sheet and then apply some simplification. So in this case, I'm going to reduce the number of polygons in the part based on an error value or a tolerance of 0.1 millimeter. So that means that the resulting simplified part will be within 0.1 millimeters of the original at all points. So if I click simplify, so Polygonica has done that in under 2 seconds. If you look here at the number of faces, it's gone down from over 400,000 down to 45,000. Just quickly show you the resulting mesh. So it's nicely uniform along the less places with less curvature, but it's preserved a lot of faces where it needs to in areas of tighter curvature in order to keep that tolerance. And now if we apply the exact same offset, just set it back to 1 again. So it's the exact same offset but on a simplified part. And this time Polygonica's done it unsurprisingly much faster, 3.6 seconds. And again, here we've got a very nice result. So 0.1 millimeters, yeah, it's not as accurate as it would be if you were doing this offsetting in a CAD BREP, but for many downstream purposes, such as many different types of manufacturing planning, work cell simulation, collision detection, etc., etc., then a tolerance of 0.1 millimeters across this a large part of this nature is fine. It's more than adequate. But also, if you want a tighter tolerance, then you only have to wait minutes to get your resultant part and not hours. So there you go. So that's a short introduction to Polygonica's sheet thickening functionality. If you have any questions, please don't hesitate to contact us via the forms at www.polygonica.com, and many thanks for listening.